All right, so I've got a problem up here. As I mentioned, the log graph that we'll be working with the most often is the natural log function. So we're going to start out graphing that, and I asked you to include the points whose y values are -1, 0, and 1. Okay. And then we're going to start working with transformations of that. Okay. I didn't write this down. I will on exams and quizzes. For the video, I'm just going to say it. Of course, we're going to track where these 3 points get transformed to, and we're going to track the asymptote. And then I did explicitly say, let's state what the domain range and the equation of the asymptote are. Okay. All right. So I might know, and it's good to know, that the general shape of this is going to look like that. I want to be sort of familiar with that, just like I'm familiar with the shape for exponential growth. And if I ever forget this shape, I can turn and flip this shape. Okay. But I do also ask that you include 3 points, the points whose y values are -1, 0, and 1. Okay. So we're looking for our y values to be these things. Now, I don't necessarily need a table of values, but I think it's helpful to remember that x is just e to the y. That's equivalent to y equals the natural log of x. It's the exponential function with that same base, the natural base of e, but with the roles of x and y switched. So my x values, this is going to be e to the -1, or an eth. This is going to be e to the 0 or 1. This is going to be e to the first, or e. Okay. Don't necessarily need to record that as a table of values if you're comfortable figuring that out just by graphing. I will remember that I'm always going to have an x-intercept at 1, 0. Shouldn't really need to calculate that because automatically the point 0, 1 is the y-intercept of any exponential graph. The point 1, 0 is the x-intercept of any log graph, at least prior to transformations. Okay. All right, excellent. And so then, let's see, we've got the point E1. Now here I'm going to need to remember that E is about 2.7. I'm going to label it as E, but that tells me where to put it. So there's my point E1. And then I'm going to have the point 1 over E, which would be somewhere between 1/2 and 1/3, -1. Excellent, with my vertical asymptote on the y-axis there. Fabulous, so that's my basic graph. Now I want to sketch this transformation. So I'm going to list what would I do in evaluating things, and then how does that transform the graph. We always do parentheses first. So the first thing I would do is subtract 1. Then I would take the natural log. That's my parent function now. So we keep getting new parent functions. We can work with exponential functions as parent functions. Now we can work with log functions as parent functions. Okay. I'm subtracting 1 before I take the log. So this is going to be a horizontal change. Horizontal shifts, remember, are a little bit counterintuitive. So I'm going to shift things 1 to the right. Okay. Now, let's see. I think what I'm going to do is actually graph the transformation over here, because that's where I've got some more space. Okay, so in shifting things to the right, I'm changing the x values, but not the y values. And I'm going to do the opposite of that. So instead of subtracting 1 from my x values, I'm going to add 1 to them. Okay, let's start with the simplest one. 1, 0 is going to move over to 2, 0. Okay. Now here, the x value was e. That's going to become e plus 1, which I will literally write as e plus 1. Now, e was about 2.7. That was about here. I'm going to add 1 to it. So instead of being just a little bit shy of 3, I'm now a little bit shy of 4. So there's e plus 1, 1. The x value here was 1 over e. I'm going to add 1 to that. 1 over e was right about here, between 1/2 and 1/3, or between 1/3 and 1/2. So now we're going to be between 1 and 1/3 and 1 1/2. So there's my 1 over e plus 1, comma, -1. Looks a little bit weird. Yes, it's possible to get decimal approximations for those numbers, but no, that's not what I want. I want the exact values. I want you to get used to the fact that e is a number, and the most accurate way you can write it down is by writing e. Anything else, you're going to be rounding. It's going to be a decimal approximation instead of the exact value. Okay, excellent. So that's our 3 points. Now, did the asymptote move? The asymptote was this line right here. It's basically x equals 0. If we're shifting everything to the right, that's going to become the line x equals 1. So I need to draw that in, and I need to draw it as a dotted line. Remember, anything that's drawn as a solid line is considered to be part of your graph. This is a necessary part of drawing the graph, but the points on it aren't points that are on the graph. Okay, and then I connect, and it's the same basic shape that we had before. So this would be my transformation. All right. So, let's see, we were asked to then state the domain, the range, and the equation of the asymptote. So my domain, well, if I take a look, it looks like it's everything to the right of 1 now, instead of everything to the right of 0. So that would be from 1 to infinity. Now here, I got that from looking at the graph, because I had shifted things so that this was where we started. I could also get that from the formula. The rule is that the argument, the thing I'm plugging into log, which when I rearrange things in exponential form is the result, the thing I get from taking an exponent, but the thing I'm plugging into the log function has to be positive. Okay? So I know that x minus 1 has to be positive. That means x has to be bigger than 1. And so on my number line, that would look like this. In interval notation, that's everything from 1 to infinity. So we're going to see some problems in a little bit where we're finding the domain without drawing the graph first, and we'll always do that by saying the argument has to be bigger than 0. And that really is just because the argument is that result. When I take my base to a power, the argument is the thing that I get. But if I have a positive number and I raise it to a power, I'm only going to get something positive. I can't get 0. I can't get a negative. All right, what's our range? Everything. Negative infinity to infinity. And that's really never going to change. Just like with exponential functions, the domain is always from negative infinity to infinity. With log functions, that's always the range. And our asymptote, well, we said the asymptote was at 1. Just need to remember that since it's a vertical line, its equation is that the x value is fixed at 1. Okay. Got to be careful, because vertical, I'm thinking, oh, y values are vertical, like the y-axis is a vertical line. But the equation of the y-axis is x is 0. X is fixed for a vertical line because we're not moving left or right. Y doesn't show up in the equation because we're not putting any restrictions on what y can be. Okay, excellent. So I'm going to have you try one of these transformations before the next video, and then we'll go over it together in the next video. So I want you to sketch y equals the log base 1/2 of x. Include the points whose y values are negative 1, 0, and 1. And then let me give you a transformation of that. So sketch y equals the log base 1/2 of x plus 2 minus 1. So it looks like there are 2 transformations going on here. Try and sketch that. Do keep track of where these points get transformed to. Keep track of the asymptote. Give me the domain, range, and the equation of the asymptote.